Hello and welcome to all the participants who are presenting in today's webinar. Well, thank you all for spending your valuable time to attend this session. Our today's webinar will be focused on AI-enabled performance enhancement and assurance services. So you all are related to plant operational performance. You know quite well what performance enhancements means. So today we will walk you through some of the intricate areas in the performance enhancement where we are trying to implement this AI/ML enabled services, which helps to enhance the plant performance in a much better in a broader way. So how we are seeing this development, we will walk you through our eyes and have a look, and I hope you will get some good insights out of this presentation. Now, we know you all are quite well aware about the services which Holtec provides across the industry in domestic market as well as globally. So people who don't know about Holtec, just a few lines about this. So Holtec is basically a ISO 9001 certified, globally established engineering, project management and consulting firm. So cement always remains our main focus of business. However, we are doing equally well in the other areas like power, highways and bridges, building materials, material handling, as well as engineering support services. So far, we have a client base across 100 plus countries. We have more than 1,000 plus clients and more than 4,800 plus assignments we carried over so far in last 57 years of our services. So recently, in 19th of June last month, we came to our 57th year of services. We're happy to announce this. So the skill sets which Holtec has are developed over a period of time. It is spread across various domains like design, R&D, project management, consulting, as well as in the construction sites. So we help a project from the pre-project stage, project stage, as well as in the operation phases as well. So we have offices in India, in Shashanklok, as well as in Uddar, Bihar, as well as in UAE, in Sharjah. One more office is there. Now we talk about our global experiences in cement industry. So you see some major areas where we have given our services, we have captured in few lines. So in new cement lines or major plant upgradation projects, almost 225 plus projects we did. Plant modification assessments, more than 1,200. Plants audits and performance enhancement assessments, we did more than 300. Through this online plant analytics and AI services solutions, we did almost 4 projects. Raw material investigations, environment assessments, more than 600 plus projects. Captive power plants assignments, 140 plus projects. Waste heat recovery power plants, we did more than 70 projects, and along with alternate fuel engagements, where we have more than 35 projects assignments we did so far. So if we talk about Holtec global experience, we have a multidisciplinary team, and we have quite a good technological competencies to serve across globally to all our clients. Now let's talk about what this performance enhancement and assurance services is, which is AI enabled. Now, if you see this, talk about your cement plant, our standard mode of services starts with performance enhancements and improvements, plant operations. So those studies our process department is already carrying. So if you see this, there's a one-time audit we do, and accordingly we go for operational improvements, plant upgradations, and we give reports, and there we give our services to our clients. Now, along with this new addition of online plant analytics and artificial intelligence, what we are doing here basically, we have online plant analytics modules. These modules have analytics as well as predictive modules. So these modules are spread across various stakeholders in the plant. So some of the analytics modules you see here, like our dashboards, our variable benchmarking, heat balance, variable deviations, AFR and raw mix optimizer, all these analytics modules, along with our AI predictive modules, both helps us to carry out or know about the plant performance. Along with this, we do recurring audits, and the ultimate outcome gives to advisory services. Along with these advisory services, we move forward with our assurance services as well, and ultimately we land up with plant operational improvements, and we recommend for the upgradations as well. So by this whole process, we talk about enhancement of the plant performance and assurance for improvement or improving some of the key variables or KPI targets, which normally plant used to follow on day-to-day basis. Performance enhancement. Sorry. The team which is involved in doing this performance enhancement activities, you can see here our OPA applications, and AI applications. Along with this, we have our engineering and technical support team. We have various multidisciplinary team involved in this whole process, starting from raw materials, process, mechanical, E&I, data science, as well as IT. So we have more than 25 experts in this team who are working continuously to help enabling plant, sorry, plant performance enhancement and assurance through this implementation of our artificial intelligence and machine learning algorithms. So we will come on details onto the services in the next few slides. Now, what is online plant analytics and AI? So this is basically a service which tells about plant performance enhancement and assurance using the big data analytics. Now, how big data analytics is helping, basically the knowledge which human being is having, it is being transferred into the computer algorithms. Then the computer itself learned those algorithms and then started delivering the solutions in a very precise way. So continuously capturing data online, monitoring the data, and then subsequently analyzing the data, which helps to achieve optimized and stable operations on a longer time, irrespective of changes of the conditions, like skills of the manpower, or the conditions of the machines, or the change in materials, and as well as the environment in which the plant is being operated. So all these activities are continuously affected, subjecting the advanced analytics and AI-enabled systems input, which almost altogether close to, you can say, Industry 4.0 approach, which helps us to unleash the potential which is already available in the plant. And then we try to investigate how we can improve the plant performance from the existing level in a much higher level where the plant can sustain. Now, let's have a look in the system architecture, how this OPA and AI implementation works. Here you can see the cursor. This is the area where plant works. So from the plant DCS, the data is being transferred to the OPC server, and we have a plant sister operating terminals. So from the OPC server, we captured the data. So data then being flowed to our data collector, which is being placed at the plant site. From the data collector, periodically, the data is being transferred via internet to our Holtec cloud. So this is the cloud area. This whole process has a series of firewalls and routers installed to ensure the integrity of the transfer and to avoid any sort of malfunctions or intrusions from outside to the system. So these are all highly secured. Captures are being done on it through specific ports. So no one can, from the outside, can enter into the circuit or do some access to this data. It is completely impossible. So now once the data is being transferred and comes to our Holtec cloud, we have first our storage. After the storage, the data is being transferred to our analytics machines. And then the data is being segregated, manipulated, and then the outlier is being removed, and the data is being ready for further working on developing these machine learning models, which then gives the insight to our Holtec specialist interface. So Holtec specialists always work on the data, this monitor the data, they see the operations, and then they give their insights through this net again and going to the client interface where we have our web-based reporting platform through which client can see the data in their desktops or laptops or mobiles at any point of time, whether they are in plant or outside the plant. At the same point of time, the quality data, which is also quite important for the analysis. So these can be uploaded from the plant directly or can be sent offline also through internet. And that these quality analysis data is also being fed to the server to understand the relation between process as well as quality, so that the analysis of the data became much more viable and the situations can be analyzed in a much better way. Now, number of data we have captured from the OPC for a typical IU plant, I will say for an example, it is given around 1500 OPC tags we capture, almost 100 lab and offline data we capture, the alarm and false, virtual data we capture, calculated data almost 220 we capture, site constants and periodically measured variables. So all these data and variables and tags are being transferred to the system for better monitoring and analysis of the ongoing operation, which helps us to predict the situation which the plant can operate in the coming time. Now, have a look in the implementation approach. So how we do about this plant enhancement study, how our approach works basically. Initially, we do a potential assessment study. So in this period, we do some preliminary assessments. We collect the baseline data as well as the past data. And based on this, we do some process measurements even, and we identify the improvement opportunities along as the areas where the performance or can be monitored, need to be monitored on a regular basis. So once these areas are identified, we went to a contract finalization stage. So in this finalization stage, we put our agreed terms and conditions and the improvements and assurance areas, which will be monitored over a period of time. So when OPS system setup has been done, after this, we do the OPS system setup where online data capture mechanism starts, data stabilization and mapping starts, as well as our formulation of AI/ML models and optimization tools come into the place. So typically this OPS set of activities and system stabilization takes around 8 to 12 weeks. So once this system setup is over, then this performance enhancement and assurance through long-term association, this block you can see, this comes into the picture where Holtec intervention starts immediately after 12 weeks, where we do start doing activations of the AI/ML models and all the tools. Apart from this, we started prescribing the key variables and the optimized operating range of the variables where the plant should be operated. And along with this, we started sharing our observations as well as recommendations for doing the improvement. In a longer sense, I will say, once the intervention starts in the picture, then comes the sustainable operation. In this period, we give all our supports for critical modifications, so periodic performance reviews, all our intermediate process studies, all our cost optimization tools, and our experiences on that specific plant. We normally share with the plant on periodic basis based on the behavior which we observe from the data generated from the plant. So it will be easier for the plant team to understand how the plant behaves and they can take actions accordingly. So these services, as it is, you can see in the block, this performance enhancement services, it's an association, I will say, rather it's a journey. It's a journey of collaboration between the plant and Holtec, which comes in the longer run and enables the system to improve over a period of time and sustain for a longer period. Now let's talk about applications of artificial intelligence machine learning for performance enhancement. How this works. Now we start with, first is digital twins. So this is one of the key criteria of, I will say, virtualization of Industry 4.0. I hope you all heard about this. So digital twins means we create a replica of your plant. So this replica is being visible here as well as at the client's end also through our reporting platform. I will come details into the later slides. So you can see this. One pyro processing screen is there, one cooler screen is there, one calciner operating screen is there, as well as one grinding screen is there. So normally as a first step, we create a digital twin to understand the key variables, how these variables changes over a period of time, and what the story basically comes out during the operation process that we start analyzing. So this is basically data analytics. So this is the, I will say, backbone of all our analysis which is being carried forward. Now, there's a bigger slide of this predator in the clean area. You can see the plant live data which has come from the plant. And based on this, some of the key analytics which we try to analyze over a period of time, which online running gives you the differential pressures across all the cyclones, the differential temperature grades across the cyclones, as well as difference in temperature and material, gas and material. So these are all dynamic. So these started moving. Sometimes it crosses the ranges or coming within the ranges. But all this speaks about a pattern in the data, which is very important to understand how the plant behaves. So once we capture this pattern, so then our algorithm starts building the blocks in the backdrop. So we started going into this prediction and the forecasting models. I will discuss in details in the later slides. So this is basically, I will say, the building blocks of developing our algorithms and the blocks. Now, one more analytics dashboards. So these dashboards are very, very important to understand and give information to the plant operation team, various departments who are involved into the day-to-day operations. So they get a very clear sense how the plant is operated, though not being inside the CCR every time. So from as I said in the earlier slides, from various machines, you can access this data, you can see how the things are improving or operating over a period of time. So analysis are readily available on your mobile or desktop or laptop. So there is one thing which you can see, this process variables range. On hourly basis, the variables values are being enlisted and tagged, and we understand how the operation is being moved. So you can see here some of the variables are red, some of the variables are yellow. So the changes in the pattern gives us an idea how the plant is being operated and with respect to some optimized ranges. This is basically the benchmark we use to create based on the data flow and the plant being operated. One of the slides showing the delta P across the cyclones, you can see both strings varied. The color coding, you can easily visible that how the differential pressure of the cyclones are changing over a period of time. So this gives an idea how your fuel or the clean feed quality or the AFRs being fired and how the relations are moving on. So there, those things are correlated with the differential pressure to understand how and why the things are changing and what could be a stable or optimized zone or the reasons which you can identify to make it much more in a much stable way for operations. Here you can see one variable deviation. This is one more ML tool which we are using to find out some of the key variables like clean feed or secondary air temperature, burning zone tertiary temperature, media temperature. So all these key variables which we identify, these variables has some optimum limits and the current values are being displayed. And if there is a deviation from the optimum to the current value, then our algorithm shows the specific reason why these deviations are being happening. So it gives us a very clear picture and a very clear insights on which of the variables are responsible and which need to be addressed on that specific point of time. So plant can take some quick actions by tracking this variable deviation page. This is also a very important dashboard. You can see here one of the observation dashboard is also there. So our observations on day-to-day basis as well as the recommendations are all being registered, and plant can see any point of time on day-to-day basis what observations we have made, whether it is in line with what plant is seeing and what we are seeing, and based on this we give our recommendations also for further improvement. So as I said, process variable range, little bit elaborated in details. You can see some of the areas are red, some of the areas are yellow, some of the areas are green. So by this at a glance, we can see how the variables are changing, how the variables are deviating from their optimized range, and what further need to be done. Our process deviation page, variable deviation page, will further guide you to understand the deviations and further actions need to be taken. Now let's see these smart modules. So in our web-based reporting platforms, these performance enhancement and assurance modules are there. Some of the models are already active and some of the models are under development. We are working closely on this to find out further improving these variables. A little bit of details into this, like our performance indicators or process indicators, there is a key indicator dashboards which says about the operations. Unit operations like live screens or graphical correlations, because in CCR you need to find out specific variables to know the relation between the operation. Here in our graphical correlations dashboard, all correlated variables are being categorically displayed in graphs or charts. So you need not to find different variables, but all are readily available for your display. So a better correlation can be seen and monitored and tracked on regular basis. Operation review, bearing temperature and vibration monitoring, all these dashboards are readily available. You can see the operation, how the things are moving. Now interventions, as I said, Holtec interventions are regularly being done with the client and sharing with the plant operation and maintenance team. Along with this, we share our recommendations as well. So there is a constant communication going on between the plant team and Holtec team. So whatever you are observing sitting here in far away from the plant, but we can share our insights through this platform on regular basis. We have different collaboration models like our meetings, our communications, and plant reports. Whatever study we're doing desk-based or on the site, everything is documented and well available into the platform. All our AI and ML models, as I said in the beginning, our AFR and ROMIX optimization, our clean condition, cyclone jamming, cement blend, strength, maintenance predictor, all various predictive and forecasting models are available in this web reporting platform. Data analytics, it is the, as I said, the backbone of all the analysis. So the data which is being available, which is being analyzed by the system and available to the Holtec specialist interface for detailed evaluation and then insight sharing with the client. So any faults happening or the cause, deviation cause. So what specific actions need to be taken. So all these things are made available in through this platform so that it will be easier for the plant team to take a quick decision rather than changing in haste some of the variable, which may help by guessing that this may help to change the operation performance or any problems you're facing that can be overcome. So all things are readily available in the platform for easy access and further optimization. So let's see a little bit about the operational dashboards, how the dashboards looks like. So we have a 360-degree dashboards for various role models. I have a couple of dashboards here to show you. So these are very specific, and you can see here, this will be helpful for the process and production team to understand, not being in CCR, but outside the CCR even, anywhere sitting across the globe, you can see the major key variables which are readily available and assimilated in a single web page. So this gives a very clear idea how the variables are behaving, how the variables are trending, and what is the relation between the process variable with the quality parameters. In the little bit, quality variables are also shown here in the below chart dashboard. So you can see there is a constant hand-to-hand communication going on between the process and the quality parameters. So this is very important to understand how the process is behaving and what further needs to be done. So all these analyses are readily available. It is available to all the plant team, so they can take proactive actions. Holtec is always sitting there to support. So this helps plant as well as Holtec for a better communication and advanced system for improving the performance. Now, after the data analytics part, the data which we are capturing, and as I said, we are building various models, blocks. So this is a review of one of the dashboards where you can see we are showing two running dashboards there for this forecasting models for Kiln burning zone as well as Kiln MD current. So Kiln torque and burning zone conditions are forecasted on continuous basis. So by seeing this, the CCR operator can have a little bit of sense in advance that the kiln condition may go down or the kiln can got hot. So when the kiln is getting hot, the people sitting in the CCR, they can take very prompt actions so that the variables range of the variables should not cross a certain limit, so that operation remains in a sustainable zone for a longer duration. In the right side, you can see cyclone 5 cone pressure. So this is one bottom cyclone, which cone pressure forecasting is also being done at the same point of time. So this cone pressure gives a pre-indication in case of any disturbances which can happen in the coming time. So these models, which helps us to get some idea in advance so that the plant team can take some proactive actions to avoid any disturbance in the operation or any unwanted stoppages which can be avoided. So over a period of time, what we can see that by implementing these models, plant upkeep can improve, plant sustainability can improve. You can follow this model. And if these models can be followed in a longer run, what we have experienced that a loss of kiln feed around 1.6% can be saved. At the same point of time, cyclone jamming, if we can avoid at least one cyclone jamming in a year, so at least 1.5% of the total feed loss we can avoid. So these models, if followed religiously, can give immense benefit to the plant operation team, what we perceive. Now have a look in the AI blame prediction. So this is one interesting thing. This is basically a time lag variable prediction, which plant people normally sees. What happens, I will explain a little bit on this. In the left side, you can see every minute blend prediction, and the right window is the actual as well as the predicted value. Now, what happens in the plant? Every 1 hour frequency, the lab is taking the sample. The sample is being analyzed and the result is being forwarded to the CCR. And then the CCR people taking some corrective actions. So if the blend is high, so you have to waste 1 hour to understand the blend is high, and when the result is come, then you are taking some corrective actions like slowing down your separator fan or slowing down your separator, something like this. These things you will take action after 1 hour once the sample analysis is being done. Whereas if we start follow this model, the model will give you a predicted value every minute, so that CCR operator will not lose time and he can take immediate actions when it is crossing the limit. So this gives a very, very, very good indication to maintain the blend, to maintain the quality of the product, even I would say. And if we can maintain this on a longer duration and religiously, then improvement in productivity as well as the specific power reduction is evident. So I hope the people who are closely related to the operation can understand this statement, because we are wasting time to improve this. And then if we get a readily available information, it can help you to improve this operation. So that will definitely give you some benefit out of this process. And by this process, the variables which are being generated at the same point of time, our dashboards are giving you always the best operating ranges which should be maintained. And if people wish to follow this, then some best operating practices will also come out from this process, and plant can maintain this. The next thing is cement prediction. So you can see we have here some key variables which says the sample frequency, our 1 day strength, 28 day strength, some of the key variables like IR lime, Na2O, SO3, blame target, and the residue. So once we feed these values into the system, oh, sorry, just a moment. Once you fit the value and give a predicting button, click the predict button, then what happens, 1 day strength and 28-day strength, actually how the operation is going based on this, the system gives you an indication that the strength of 1 day and 28-day will be somewhere lying like this with respect to your target range. So from this, our AI models will start giving you a prescriptive analytics to improve your blend target. Now, what happens, though your blend target is 300, but by seeing the strength, which is already high, and you are delivering higher quality to the market, so you can reduce your product blend. So once you reduce your product blend, the strength will get matched. So you can get an idea from this prediction model how the operation is moving and what further need to be done to improve the strength of the product. Because you see, the underlying concept of this strength model is we need not to give poor quality product in the market, neither we will give higher quality product also. So the range setting, the closer the range setting, say my target strength is 56. So if I can maintain plus minus 1, probably I will be the most happiest person to give a more justified product to the market, where my business ethics will also get justified, as well as my client will also get satisfied. They will never get a lesser product. So early prediction of strength, 1 day and 28-day, will definitely improve the quality of the cement. And it gives a confidence to the team that we are not giving any point of time any lower quality or any high quality going to the market. Now let's quickly have some case studies, have a look what we did so far and what our experiences coming out from this whole process. So this is something, a plant where we work on a grinding for a PPC grinding project, where when we started the plant during the initial process, we found something around 26.6 power with a 0.62 clinker factor and a throughput of 243 TPH. So based on this, we took some baseline values where we can improve the plant or take the plant to the upper level. So we have given some sort of targets, targets of 3%, 2%, and 4% of the throughput. And over a period of time, through our interventions in the terms of engineering and process skills, as well as with amalgamation of the data analytics modes, we achieved around 9% improvement in the grinding efficiency, grinding specific power consumption. Little bit less, but yes, without any capex or without any investments, the latent potential has been extracted from the plant, and we could able to reduce the clinker factor to 1.45%, and throughput was around 2.5%. So again, the targeted throughput, though it is a little bit less, but you can see in the lower table. So the initial fineness, when it started this project, it was 7.5, and the latest stage with the development in the plant, so plant changed the target to around 7.1. So once the fineness got reduced, so by this process, they increase in the strength also. So it's quite evident from this data that there is some improvement in the process, improvement in the quality of the product. So client got some sort of confidence on the product quality, and then they reduce the fineness of the product, they increase the strength. So somewhere, in some way, they got some sort of benefit out of this whole process, clearly visible from the specific power as well as the clinker throughput. One more plant in the grinding, in the OPC grinding, you can see. So when we entered into the plant, there were certain parameters for OPC 53 and 43. So before our interventions, there was some parameters, and once we started intervening into the process through our AI-enabled approach, so we could able to increase around 4.2% throughput in OPC 53, around 3.6% throughput in OPC 43. At the same point of time, we could able to did some energy, specific energy reduction on the system over a period of time. You can see here to the waterfall graph. So over a period of time, in 3-4 months time, we could able to reduce 6.3% reduction in our 53 specific power consumption and 6.9% in 43 specific power consumption. So apparently it gives us a confidence and strength that yes, the approach we are following to improve the plant performance with the help of the data analytics, it's quite deep, and over a period of time it will emerge and it will definitely bring a lot of benefits onto the table, which we are reasonably confident on this. So overall benefits, if I talk about on the OPA and AI services, so you can see, we talk about improvements in efficiency and sustainability, where process sustainability, our energy efficiency, product quality consistency, optimization of the costs, our exposure to technical developments, and customized applications. So each and every plant is specific. So we target a way that each and every plant requirements will be fulfilled in that way the plant is looking for, basically. And at the same point of time, our interventions, which you can see in the right window, all our improvement measures, what we recommend, recommendations are placed in the platform are based on online data evaluation. So we need not to sit in the plant. We are far away from the plant, but still our algorithms and our analytics modules are giving a fair amount of idea how the things need to be managed and how the plant need to be operated. So real-time consultations are always being done with the plant team. So there is no hindrance. Any point of time, plant can call. Holtec is always there for your support. And all the implementations, what we recommend are all risk-free, because some of the areas we do some non-destructive testing, I will say. So before implementing something, we do some simulations at our end. So we test the things at our end before advising our client to implement this. So far, our experience goes quite well, and whatever implementations we did, all are given a good results, what we have experienced in the recent past. And implementations are all based on Holtec design, engineering, and operational capabilities. So, Holtec has a huge experience of 57 years across the globe. So the database which we have, it's very huge, and the references are remarkable. So before implementing, we apply all our databases supports, and then we accordingly recommend to the client that this sort of recommendations will be beneficial for you. Nevertheless, there goes discussions and joint discussions happened before implementing any of the recommendations which we share with the client. Let's see a value proposition. This is basically coming out from our experience, what we did in last 6-7 years of period, or wherever we have implemented this system. So our main focus always remains the improvements should come within the existing infrastructure, because what we have experienced, each and every system has its potential. But most of the areas we have seen that all the latent potential has not been extracted. So some sort of gray areas are always visible. So once we implement our system, those areas becomes visible. The deviations in the variables become visible. The potential of the particular variables become visible. So once we captured those variables and started intervening, over a period of time, what we have seen or experienced, we are sharing with you. So if we talk about system KPI improvement, so we have seen that the system's throughput to the extent of 3 to 5% is quite feasible. Power consumption reduction around 4 to 6% is quite feasible. Heat consumption reduction is also highly feasible, provided the data which we are getting online are all coming in a continuous way, and along with the quality part also, as I said. So online quality as well as process, both these helps a lot. Like if we talk about clinker factor reduction, that is also very important. And yes, it is feasible. All the things are viable, provided we have hand-to-hand data of the quality as well as the process. A for enhancement, we are already working on this, and reduction in carbon footprints. So these are the major system KPIs which we think are feasible or implementable over a period of time. For sustainability maintenance, we talk about our data modeling, we talk about our data analytics, and through this prediction and forecasting modelings, we predict for prediction for the time lag variables, as I said, for the blade as well as for the strength, and forecasting for some key impacting variables which are immediately need to be addressed to avoid any sort of unwanted stoppages. So people should have a very closer look onto this. Once we analyze the data over a period of time, if we found that yes, some sort of capex infusion will be required for any system modification, so our engineering team are closely working with our analytics team or this OPA team, so that design and implementation for such an optimum solution can also be provided to the client. So this is also a alignable part of our OPA services. So as I said, this our web-based reporting platform, you can see. So this platform is available in your desktop, in your laptop, in your tablet or mobile, anywhere you can see. So these web-based reporting platforms having various areas like running of current running as well as the historical plant data. You can see for the many past years the data which is being captured, because normally in plant operation, we are quite sure, because what you have experienced in any of the plant, normally data are being stored for 6 months, 3 months, or maximum 1 year based on the capacity of your server. But in this case, there is no limitation of storing the data. So the data can be stored for a vast period. So once the data is stored, the nature of the data is being studied. So the pattern, what the plant says with different conditions, with seasonal variations, with change of operators. So all these things are being studied in the background. And the ultimate outcome is the models, as I said, the prediction forecasting models, which further gives a better insight into the plant operation so that Holtec will support along with plant can take their own actions over a period of time. The data is being monitored, analyzed, and relevant variables are kept in track for analysis. All interventions what we made with the client are available in this platform, and all communications are also being tracked. So plant can take their own decisions, or they can always consult with Holtec before implementing any of the actions which Holtec recommends. Now, what are the applications of this artificial intelligence machine learning? Its advantage and present as well as in the future, what is going to come. So if you see from the first point, prediction models basically help us to define sustainability of the key operating variables, which are readily not available. So on present scenario, those variables cannot be seen readily. So those variables can be predicted so that my performance, my sustainability in the operation can be improved, like blend strength, clinker free line, etc. AI-based forecasting models. So these models are something which will forecast for certain period in advance, so that those variables, if we can forecast in advance, that can help in avoiding process disturbance or any unwanted stoppages of the plant, like cyclone jamming or clean and cooler conditions. So those things can be addressed in advance. Deviation models. Again, AI-based deviation models are help to identify the deviations on real-time basis. So the variable changes, and on real time, we can identify the deviations, cause of the deviations, and take proactive actions so that my operations remain in a much optimized way. Like as I said, preheater outlet temperature or secondary air temperature, burn engine temperature. So there are other lot of variables. I have just kept few of the things for example. Coming to AI-based optimization tools, these tools are very important for the plant team to operate at any point of time, like our AFR and raw material optimization tool, which helps to maximize the TFR, to improve the clinker quality, to minimize the fuel cost. And these things can be done on periodic basis in the plant operation, so that plant can get a very good insights from this platform, from these services, and improve the performance in a much better way. One more thing is AI-based information retrieval mechanism. This is basically a retrieval augmented generation, I will say. This is a more rather term in a present day scenario, which helps the LLMs, that is large language models, which are being used. I hope you all know about the ChatGPT. So like this, we are already in the process of developing such sort of mechanism, which will help specific plant to identify the problems in their plant. So for this, all the data and information need to be fed into the system so that the system can, with a single keystroke, you can identify the root cause of the problem, why the things are happening. So this is also a new thing which we are working as of now. So enhancing the plant performance with the help of artificial intelligence and machine learning models are very, very important in the coming time, which are very specific developments are required. And all these developments are tailor-made and based on plant-specific conditions. That means something developed for a plant is not applicable for other plant. It is not possible, because each and every plant operational and quality data are unique, and their story is unique. So the models has to be built in such a way that they should understand that story and reveal the condition of that plant and how further it can be carried forward in the over a period of time. So sustainability operation, cost reductions are prime focus of our services, and we hope that AI would take a very center stage in the coming time for improving this plant performance. So with this, I will end this presentation. So basically, collaboration between client and Holtec is AI-enabled implementation of performance and assurance services. This can bring numerous advantages and innovations over a coming time, as we have observed. So we are quite confident that this approach will help the plant to gain more out of these services and lift their operational performance in the coming time. So with this, I will stop this presentation